All right, good morning, everybody. Thanks for coming out. My name is Rowan. You're here hopefully because you want to hear about Entity Framework Core. We have a very simple agenda today. We're going to start with just a little bit of intro. You're all here because you're developers, so we're going to spend the bulk of our time in Visual Studio writing code. At the end, I'm going to leave you with some next steps, URLs you can go to, people to follow, etc. Just so I know who I'm presenting to, how many folks in the room have used EF, are somewhat familiar with it, have been to a demo? Everybody, great. Same thing again for Entity Framework Core. How many people have either used it or been in a talk? Most people, great. That's exactly what I built this talk for, so that's good. 30 seconds if you're not familiar with EF, because there were a couple of hands that didn't go up. Entity Framework, or EF for short, is an object relational mapper for .NET. So that means I have my classes, like customer, which has an ID property and a name property. I have tables with columns in a relational database. EF is the glue in the middle. So it means I don't have to write raw SQL statements. I don't have to worry about taking result sets and mapping those into my classes, etc. For .NET means it's specifically built not just to run on .NET, but it's built to work well with the application architecture and the coding patterns that are common on .NET. Entity Framework Core, in particular, is a new version of Entity Framework that's built to be lightweight and extensible. So you can think easier to override, better performance, smaller when you deploy it, and then also cross-platform. So it runs everywhere that you can write .NET code. Obviously Windows, but also Mac OS, Linux, iOS, Android, and then of course all of the Windows devices like Xbox, phones, etc. Here's another way of thinking about that. So Entity Framework has been around for many years now. We've had lots of versions. It started in the .NET Framework 3.5, and because it's built for the .NET Framework, it is Windows only. Entity Framework Core, on the other hand, is quite new. It's built against .NET Standard, and so is cross-platform, and we currently have version 1.1 out. Now, what's important here is that EF Core is not like an immediate replacement or the next version of EF6. So both of these trains continue to go forward. But EF Core will be the place where all the innovation is going forwards. EF6 is still very much supported, but it's going to see more like minor improvements and bug fixes over time. So while we might be doing more innovation in EF Core, EF6 is still a go-to stack for a lot of people these days. In terms of adoption, we see about 10% of users using EF Core and about 90% still using EF6. And just to reinforce that these two trains continue to go forward together, EF Core 2.0 Preview 1 was released this week at Build, and EF 6.2 Beta 1 will be coming out very shortly. Okay, so we've finished all the code changes for it, and we're just working on getting the release published at the moment. Here's one last way to think about this. This slide you've probably seen if you've been in a .NET talk. This is how we think about the .NET landscape these days. EF6 is a runtime component, but it was built before any of these boxes existed. So it's compiled specifically against .NET Framework. You use Visual Studio to write apps for Windows. EF Core, on the other hand, is built with all of this in mind. It was built at the same time that a lot of this was. So it targets the .NET Standard, and therefore it runs on all those platforms and can be used with all of the various tools. All right, I promised the slides were going to be short, so let's dig into demos. So I'm going to start by running through a series of demos using the preview that's out today. So this first set of demos you can go and do yourself at your desk by getting the packages off NuGet.org. And at the end of the talk, I'm going to give you the URL to all of the source code for the demos as well. At the end of the talk, I'm going to do a couple of demos that are more future-facing. And I'll be very careful to call that out when we hit that point so that you understand that those are not demos you can go and get bits for just yet. The first demo I want to do is a new feature called Global Query Filters. So let's swap over to Visual Studio. OK, so here I have a very simple EF model. So for folks that aren't familiar, an EF model is made up of entity classes like blogs and posts. And then we have something called a context that ties all that together. A couple of interesting things to note about this particular model. So post has an isDeleted flag. So this would be like a soft delete scenario where I never actually physically delete data from the database. I just flag it as deleted and should then be filtered out from the application. The other thing to note is that this is a multi-tenant scenario. So I have data for multiple users in the same database. And the thing that distinguishes which rows belong to which people is the tenant ID on blog. So this would be effectively a username. And then I've done a bit of work here in my context. So when I create an instance of my context, I pass in the tenant that it's connecting to. And then I've written a bit of logic in save changes that says, when I'm saving a new item, go and set the tenant ID to the current tenant. And if I'm trying to delete a blog, so a post, I pull up all the post entities that are deleted, I actually go and swap those to be modified and set the isDeleted flag instead. So I have the data persistence sorted out, but let's look at what happens with query. So in my program main, I've written a bit of code here that's going to get all blogs from the database, write out their URL and the tenant, and then it's going to get all posts associated with those blogs, and write out the title and the isDeleted flag. Let's run and see what happens at the moment. What we'll see, I'm connecting as Rowan, and so I see my data coming back, but you'll also notice I'm seeing data for other users. I'm seeing data for Jeff. And the other problem is I'm getting isDeleted true in my data as well. So let's try and fix some of these problems. So I'm going to go to on-model creating in my context. On the model builder, I'm going to pull up the configuration for post. And then I'm going to use this new method called hasQueryFilter. And we want to filter out deleted records, so we're going to do a not on isDeleted. OK, so I've defined this globally in my context. I now run the application again. And we'll see that the deleted stuff is getting filtered out. OK, so that applies right throughout my application. Now, some of this was possible in EF6 if you did a bit of hacking around. It was fairly easy to say, whenever I get this set on the context, filter out the data. But I'm actually not querying against the posts here. I'm querying against blogs and including the posts. So the nice thing about global query filters is they don't just apply when I'm querying that entity. They also apply when I include related data in a query as well. The other problem I had was multi-tenancy. So let's go back down. We're going to use the same approach. So again, this time we'll pull up the configuration for blog. We'll use the hasQueryFilter. So we're going to say the tenant ID is equal to the tenant that I have set on my context. Now, one interesting thing here, for folks that know about EF, on-model creating actually only runs one time per app domain per context type. So this is going to get run for the first context that is created, which might be connecting to tenant Rowan, but then later I might create a second context that connects to tenant Jeff. Now, because on-model creating only runs once, you might think that this is always going to be set to Rowan because that would be the value of this field the first time it runs. Query filters are actually smart enough to know that this field is coming, it's a bit of instance data on the context, and so it will actually lazily evaluate this against the instance of the context that the query is running against. So you don't have to worry about doing any special magic with caching models, etc. Let's run our app again. And now we see the tenants are being filtered to just mine. And again, this filter applies right throughout the application. Cool, thank you. The next thing that I want to show you isn't really a new feature in EF Core 2.0. This is something that we've been working on in EF Core over the latest series of releases. So in EF6, we were very opinionated about the shape of your entity classes. You had to have properties, they had to have getters and setters, etc. In EF6, the 1.0 release started out with those same restrictions. But under the covers, we'd built the stack to be much more flexible. And so over this latest series of releases, we've allowed more and more flexibility in the shape of your entities. So let's swap back to that same application that we were just working on. Think about tenant ID. It doesn't really make much sense for that to be exposed in my application, right? The application should never really need to reason about this data. It also makes absolutely no sense for it to be settable, because the application shouldn't be changing the tenant that data belongs to. So instead of making this a property, let's shorten it up and make it a field. And then if we scroll up here, I'm going to pull in a piece of code, because you don't want to watch me type all the time. OK, so what is this piece of code doing? I'm pulling up the configuration for blog. I'm saying that conceptually in the model, there is a property called tenant ID that is of type string. Note that that property does not exist on my entity class anywhere, but I'm saying that that property maps to a field on the entity class called _tenant ID. Now the problem I have is I can no longer do this in my link query or in my global query filter because there is no property and I can't access the field because it's private, which is exactly what we wanted. So what I can do is use ef.property. We're going to say there is a property on blog that is called tenant ID. Like this, and this will tell EF to go and find that property that is conceptually in my model and apply this filter to it. Now, the other problem that I have is I can no longer access tenant ID here, right? And that's by design. We don't want to be able to. So I'm actually going to delete this code. Now, I could get to the data if I really wanted to. On the context, there is a change tracker where I can get at the data and start manipulating it. But I really don't want that to happen. Once a blog has been saved, the tenant should never be changed. There's no API for that directly on Model Builder, but one of the core things that we tried to do with EF Core is not have a top-level API and then hide everything else under the covers. We tried to have a nice top-level API, but you can easily drop down and really manipulate the low-level stuff if you want to. So that's exactly what I'm going to do here. I'm going to drop down to metadata. Metadata is the underlying object model that represents all of the data about this entity type. And I'm going to say is read-only after save equals true. And this now means I can no longer manipulate that value. Once it's saved to the database, EF's going to throw if I try and change it. And let's just run again, make sure we're still working. Cool, so we're reading and writing from the field. We're applying our query filter as we get data from the database. Now let's think about is deleted. Is deleted doesn't even really make sense to have in the entity. Is deleted is always going to be false for everything that's in memory. So let's just delete that altogether. And then we're going to introduce another little snippet of code up here to say there is conceptually a property in the model called isDeleted of type Boolean, but I haven't told it to map to a field. I haven't told it to map to a property. So EF is going to keep track of this data in the context, not in the entity. And again, I can't write that piece of code, but I will just pull in exactly the same thing that we just did for the tenant ID. We'll use the ef.property method. And again, we'll just have to delete that piece of code from here. OK, let's run again. So with EF Core, I've been able to map to a private field. I've been able to store data that's not stored in the entity at all. And I've been able to apply query filters, et cetera, based on all of that data. So you can see we're getting a lot more flexibility about how we would map to a model. Should also point out, when we talk about flexibility, it's obviously a spectrum. So EF6 was way down here, super rigid. When we think about where we might want to go in the future, there's a whole bunch of other things we could do too. We could do constructor parameters, get and set methods, things like that. So I'd say with EF Core, we're kind of somewhere in the middle at the moment, but that doesn't mean we're done. We're going to continue pushing the bar to get closer and closer to allowing you to do all of these patterns. Now let's turn to something a little more technical and under the covers. So context pooling is a performance feature that's new in EF Core 2. I'm going to explain this one using some slides before we demo it, because it's perhaps a little bit complicated. OK, when we have a request come in ASP.NET Core, we have something like a controller like this. We have a context that is injected into the controller via dependency injection. And then we run some actions against that context. So in this case, I have a blogs controller. The index method just returns all blogs using the context. So the way that works, as I mentioned, we have a dependency injection container, a collection of services that can be pushed into my controllers, et cetera. And one of those services would be the blog context, sorry. So when a request comes in, a scope is created in the container. And a scope is just a way of saying, there are some services that should be unique to the request. And a context is one of those. We definitely don't want to share context between requests. So when the scope comes in, a new context instance is created and passed into the controller. And then that same thing happens for all subsequent requests. And as the requests complete, all of that stuff is torn down and thrown away. Now, the interesting thing about a context, as well as the state of the data, there's also quite a bit of setup that goes into a context. It's not just one class. Under the covers, the context is made up of a pretty big collection of individual services. So that's where context pooling comes in. In my DI container, I have a pool of contexts. A request comes in. One of those contexts is allocated to the controller, and then the same thing happens for subsequent requests. And then at the end, when those requests are finished, the context is cleaned up and returned to the pool. Cleaned up is obviously very important. We don't want the next request to get a context that already has data and state in it. So we tear out the things that we need to, but we leave all of those objects allocated in memory. So let's see this in action. I'm going to swap to a different project here. We'll just set it as our startup project. And I'm going to walk through what this code is doing. It's emulating the core pieces of what would happen in an ASP.NET application with regards to services and how contexts are allocated, et cetera. So the first thing we do is create a service provider. It's effectively our dependency injection container. We then spin up a thread to monitor results, and you'll see what that does in a second. And then we go and spin up a whole bunch of different threads that are going to simulate continual requests coming in and getting services from that container and to process the request. Let's go look at what that method does. So while our test is running, we go and we create a scope in the DI container, in the service provider. We get the context, which again is going to be unique to this request. I run a simple query on it, and then I'm doing a bit of thread safe field incrementation just to make sure I keep a track of how many requests I've serviced. And then if we go look at the context, I'm doing the same thing here. In the constructor, I'm keeping a track of how many instances of the context were created. So let's run this application. I haven't done anything with context pooling yet, so we'll see some results come out. You'll notice because we're creating a new context for each request, we end up creating 90,000 contexts, and we got through about 9,000 requests per second. So let's just pop that one over to one side. Go back to Visual Studio, and instead of add DB context, and this is the code that would be in startup.cs in your ASP.NET application, let's swap to add DB context pool. Now in a minute, I'll talk about why this isn't the default. Let's run our application again. Put these two side by side. So we can see here with that very simple change, we've gone from creating 90,000 contexts down to creating 32, and we see a significant increase in throughput from 9,000 to a little bit over 11,000. Now the question would be, if this is so great, why would I not just make this the default? Because we're doing that process of cleaning up contexts, putting them back on the pool, we need to be really sure that when we clean the context, it's actually clean. So if you are doing anything advanced with your context, you're storing some state in it, think about my multi-tenancy scenario, pooling is going to break that stuff by default. So the reason it's opt-in is because you need to be very aware of some of the restrictions and considerations you need to use when using pooling. But how many people like that number, right? That's good, yeah? You have to excuse me pausing. I have so many things plugged in up here. I have like 6 buttons that do stuff, and I always forget which one is which. And the labels don't match at all. So when you see me staring blankly at the screen, that's what I'm doing. OK, when we started building EF Core, we had this vision. We actually started, it wasn't even EF Core. It was called EF Everywhere. And it was the idea of taking the EF stack and being able to make it run anywhere that you write .NET code. You might remember that we published a spec on that quite a while back. Then EF Everywhere turned into EF7. And then EF7 turned into EF Core, which is what we're talking about today. So let's look at some of the places that we can run EF code. I have a project here called Unicorn Launcher. For folks that don't know, unicorns have always been a little bit of a mascot for the EF team. We had this weird propensity for super long names, us and everyone else at Microsoft. When we first started working on code first, I think we had the Microsoft ADO.NET Entity Framework Community Technology Preview February 20-something name. And Scott Hanselman, who's always like good at poking a bit of fun at teams at Microsoft, was like, whatever, it's the Entity Framework Magic Unicorn Edition, which was way better, and it kind of stuck. So unicorns have always been a bit of a mascot. So this app would be, I guess, for the Unicorn Space Program or something like that. This is a place where they can come to control their launches, etc. They want to store their data. At the moment, they're just launching, but they're not really keeping a record of when they launch, etc. And they've started implementing an EF model here. So they have an entity called a launch, has an ID, they're recording the time of the launch, and then optionally some extra information to help them remember what this launch was about. And I have a context here too. Now I want to store the data locally, and I happen to have the SQLite provider for Entity Framework Core installed. So on Options Builder, I have an extension method for use SQLite. Now fortunately, SQLite connection strings are easy, or at least easy compared to every other connection string. How many folks in the room Google SQL Server connection string every time they have to write one? Actually, the scary thing is that's a lie. I don't need to anymore. But. OK, so now we have the context set up. It's going to hook up to a local SQLite database called data.ui. The provider is going to pick the appropriate place. It would be user profile in this application, because this application is a universal Windows platform application. All right, let's just close down some of these tabs. Now, there's a couple of different screens that we're going to work on. So the first one is the launch screen. So they have this helper method already to record a launch, and we just need to fill it out. So they're creating an instance of the launch entity, recording the time as now and putting some info. In this case, it's a build demo launch. And so now we're just going to spin up an instance of our context. That's not what I wanted to type. That is. So we're going to get the launches DB set, and we're going to go ahead and add in our launch. And then we're just going to save the changes to the database, flush those changes. Just while I'm here, one interesting thing. In EF Core, we actually also have an add method directly on the context. So you can actually do this as well. This is nice if you're not exactly sure what entity type is coming in. You can just dump it in the context, and we'll work out which set it goes into. OK, the other screen that we use is a history page. So this will allow us, it's basically just a data grid that will allow us to see which history of launches. OK, so we can see what's in the database. All right, so if I scroll back up to the top of this launch controller, you'll see that I'm doing a bit of work with GPIO, so general purpose input-output pins, APIs that are native in UWP. And the reason I am doing that is because we're actually going to take this application, and rather than running it on a Windows device, we're going to go ahead and put it on this Raspberry Pi that I have here. So I'm just going to start the deployment on this end. Takes about 30 seconds to deploy, so just give us, it might actually be quicker because I already deployed it once. And my Raspberry Pi device is running Windows 10 IoT Core. So I wanted to have a little bit of fun with this demo because we're going to digress for a little bit and talk about something that's not necessarily Entity Framework. So let's swap back to our IoT board here. So let's make this thing a little bit more real. So I have my Raspberry Pi. The first thing I'm going to pull in is a relay board. So a relay board, which I'm going to hook up. So we're going to hook up positive and negative. And then we're taking one of the GPIO pins, which is this little orange cable, and we're going to hook it up to the input on the relay. So what a relay does is allow us to use the small amount of current on the GPIO pin to switch a larger amount of current using this relay here. The current that we're going to be switching is going to come from this guy, which is a 12-volt power supply. So I'll just hook that in. And then the thing that we're going to be switching is this guy, which is called a solenoid valve. So a solenoid valve just allows us to use electricity to control the flow of something. So this guy was actually built for a cutoff switch for fuel in a car. Just happened to have it around from a different project I was working on. Solenoid valves also what you would get if you were turning on an electronic sprinkler in your garden. Now, because I'm going to be switching something, and this is a demo with people in the room, we're going to be safe, so I'm just going to put a pressure regulator on this guy so we don't injure anybody. I kept this demo very quiet. I didn't tell anyone at Microsoft because I could totally see the like, I'm not sure if that's a good idea. All right, so. Don't worry, I'll switch the camera off in a minute so you can actually see this thing properly. So we're going to hook that up to the solenoid. Now, I'm just going to run a test because I've just done a whole bunch of hooking up wires. I just want to make sure that we're actually. Cool. All right, we're running. OK, so then. This felt super dodgy. I'm like walking in holding this air tank with compressed air in it. Like, no, really, this is legit. I'm a speaker. Look, I have a Microsoft jacket on. I've done this before in my room at home. My son loves it. All right, and then I'm just going to, we don't want to hurt anyone, like I said, so we're going to keep this at 50 psi. OK. So, little foam rocket. Let's pop that on. All right, let's move the camera back a little bit so we can. All right. If you get motion sickness, I would advise not looking at the screen for just 1 second while I. There we go. OK. I really hope this works. There's so many moving parts in this, it's not funny. OK, let's fire up launch control.
Good morning, Build. Welcome to launch control.
All right, here goes. Let's hope this works.
Launch initiated. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Yeah. I still smile every time I do that. All right, I can relax now. The part of the demo that was going to fail is done. I shouldn't say that, actually. That's the setup for failure, if ever there was one. Point of that demo, EF runs everywhere. IoT is fun and cool. Yeah. And as much as I wanted to pretend that that was for my 4-year-old son, it was totally for me. But you all clapped, so you liked it just as much. All right, let's swap back to something more serious. When queries execute in Entity Framework, there's a bit of a process they go through. When EF sees a query, it gets a linked tree. Think of this as like the object model that represents the query that you want to run. And so EF, I'm going to overly simplify things here. First off, it works out the shape of that query. It comes up with a lookup key for it. So we can think of this as like hashing the query tree. Once it has that hash, it then looks in the cache to see if this is a query that I've translated before. If it hasn't, it goes ahead and translates that to SQL. And then so that it doesn't have to do that process again, it puts that in the cache and then executes the query. This happens automatically under the covers for you. So in EF Core, you don't pay the cost of translating every query to SQL. Obviously, that's quite expensive. But you do always pay the cost of working out the hash of the query tree. Now, for most cases, this is fine, because it's a very small overhead. But there may be some hot paths where you run the same query over and over and over and over again. You can imagine if you have a web page that looks up the user by their current ID, that might get hit by every user session multiple times. And that's a piece of code that we really want to optimize. Swap back to Visual Studio. I'll just pull up the next demo here. So that is exactly the scenario I have here. We have a console application, and we're going to go and run a test. So what I'm going to do is write 2 pieces of code, and then I have a harness that's going to run them and test them. The first one is going to connect, I'm using AdventureWorks to connect the AdventureWorks database. And this test is going to give us a set of account numbers. So we're going to create a context and then loop through those account numbers and pull back the customers one at a time. Now, obviously, if I wanted to pull back a bunch of customers, this is the slowest way to do it, doing them one at a time. Typically, I would write a big query to pull them all back at one. But what we're trying to demonstrate here is not the best way to pull back a bunch of customers, but we're trying to iterate the same query multiple times. Now, I am using a different ID on each execution. And the query cache is smart enough to understand that just because the parameter has a different value doesn't mean it's a different query. So it's going to reuse the translation to SQL for each execution. I want to make sure the test is fair. So before I do any of this, I've gone and queried for a customer here. And this is actually going to slightly benefit the uncompiled case because the translation is already going to be in the cache when we get to the compiled query case. The uncompiled, sorry. All right, so now we need to go and implement this using compiled queries as well. So I'm going to copy the code, and then we're going to change it to use compiled queries. So the way I create a compiled query is using the ef.compiledQuery function. And then I specify the parameters that it's going to take. So the first thing, the query is always going to need a context to run against. And then for this particular query, it just needs an ID. And then I say, given those inputs, this is what you run to get the result. So we'll just copy the query. Now that translation is effectively going to be stored in this variable. So if I was using this in an application, this would typically be static somewhere in the application. Or if I was using ASP.NET Core, it could be cached as part of a singleton service that's used everywhere. The point is this is like one translation of the query that I'm going to reference via this variable here. So then down in my actual body, instead of running the query using link, we're going to use our compiled query. We're going to pass in the context and the ID. It's important that we pass the context in, because in this case, I'm always running it against the same context. But that wouldn't be the case. In an ASP.NET Core application, every request has a different context, but we still want to make use of the same compiled query. OK, let's run, see what happens. OK, so it makes quite a significant difference, right? Yeah. Now, not all queries are going to benefit the same from this. It really just depends on how complicated getting the hash is, how often you run the query, et cetera. I happen to be running this one 500 times very quickly. So it's kind of perhaps a situation that's skewed a little bit towards compiled queries. But that's kind of the point, right? We don't want to use this everywhere because it makes our code messier. We want to use this in places in our application where we know we're going to be running the same query over and over and over again. One of the other features that we introduced in EF Core 2 is ef.functions. So this is a C# API over some common database functions. These could be functions that are general to most databases. They could be functions that are specific to a relational database. Or they could be functions that are added by the database provider that are specific to that particular type of database. So far in EF Core 2, we've just kind of enabled all of the framework to allow this to happen. There is one function that we have at the moment implemented. But there'll be more and more added in the future. And like I mentioned too, database providers are free to add functions for their own particular functionality, which is great. Let's pull up the next project. So there's a few different things in this project. That's not the one I want. Blog service. Blog service is like a helper service. It takes a context in. So it's like a service that it requires. And then we have a single method on here to search blogs. And I pass in a term. And then I'm currently using a raw SQL query to go and run a like comparison in the database. And then if we run the program, we'll see that this works. The program is basically just going and saying, give me all blogs that have cat in the title. Now, where this is a bit of a problem, here I have a unit test. Now, we enabled this pattern in EF Core where you can pass services or pass options into a context externally. So by default, if we go and look at my context, I'll just open it up for you. I have a default constructor here, which is what I used in my console app. And then in onConfiguring, I am pointing it to use SQL Server. But I have a second constructor as well, one that takes DB context options, which allows me to set up the database, et cetera, externally. And then I just have a little bit of logic in onConfiguring to say, if something was already set up, just forget the SQL Server thing, use whatever was passed in externally. And that's what we're doing in our test. We're creating a context options. We're using an in-memory database. This is a change in EF Core 2. I can now give these names, which makes it way easier to control the scope. So for this test, I'm inserting some instance data, which is very specific to the test. So I've created a name that is specific to the test, meaning this is the only test that will use this in-memory database. But if I had a bunch of read-only tests that could easily reuse the data, I could share the in-memory database instance between all of the tests as well. You could do this in EF Core 1. It was just really difficult because you had to muck around with service providers, et cetera, to control it. So now you have a super easy way of doing it. So we look at this. We're inserting some well-known data. Then we're searching for AAA and expecting to get 2 results back. Let's load up the Test Explorer. We'll see our test is there, and I'm going to run it. OK, and it fails, which is a problem. Obviously, that was an obvious statement of the century. All right, from SQL is currently not supported. So the problem is, from SQL, I pass in a raw SQL string. We're obviously not going to go and implement a SQL translator in the in-memory database. So let's go back to our service and see if we can do this another way. Instead of using from SQL, let's do a where. So ef.functions.like. The thing that we want to match on is the blog URL, and the thing that we want to match is my like expression that I have there. So with that change done, let's go back to Test Explorer. Try running our test again. This time it passes. And if we run our application, we'll see that everything is still working there as well. It's running it. It's going to translate to the same thing. It's actually just going to do a straight up like in SQL Server. But obviously, database providers are free to translate that however they like. Tidying up some tabs here. So in this next section, I want to talk about some stuff that's coming up in the future. So I just want to be super, super clear. I've said this like 3 times, and I'll say it one more. This is not stuff that you can go and get off NuGet.org right now. OK? The first thing I want to demo is something called owned entities. Folks probably heard of complex types in EF6. So owned entities are kind of complex types plus a bunch of other stuff that we plan to add in the future as well. So think of this as, it encompasses much more than just complex types. You can think of it as starting to head down the path of supporting aggregates from DDD, et cetera. Now, this is in a nightly build, which means this stuff is all checked into our current working code base. That will be the code base that EF Core 2.0 ships from. So while this isn't in 2.0 Preview 1, there is some very early start to this work, but it won't be able to do everything that I'm going to show you on stage today. But it is going to ship in EF Core 2. So you can expect to be using this in the nearish future. So this is kind of a canonical complex type scenario. I have a customer. They have a work address and a physical address. An address isn't a different entity. I can't just create an instance of address and save it to the database. An address always has to be assigned as either a work address or a physical address. And so to that end, the address property, the address class has no primary key, et cetera. It's just kind of inline data that belongs as part of customer. And if we look at the implementation of my main method, I'm basically just dropping and recreating the database using Entity Framework. So what this is going to do is going to give us an easy way to look at what EF is expecting the schema to look like. Now, I could, of course, be using this to map to an existing database just fine. The point of dropping and recreating the database from EF is just to show us what EF thinks the database should look like. If I run this application now, we'll get an error. And the problem it's going to say is that entity type address requires a primary key to be defined. So it's trying to map address as an entity type, but it can't because it doesn't have a primary key. Let's pull up Model Builder. We'll pull up the configuration for the customer entity. And then we're going to say it owns 1. And let's do physical address first. So this is saying the customer owns that address. It's part of this entity. And then let's just copy and paste that. And we'll do the same for work address as well. Okay, so let's run the application again. I'm going to swap to SQL Management Studio, which appears to have closed. So let's open it up. Now you'll notice that we called it owns one because we may have the concept of owns many in the future as well. Like I said, this is the start of something that we envision growing into a much bigger feature. So I'm connecting to my LocalDB instance. We'll look at the owned entities database, the tables for that, single customer, all of the data inlined. Because it's a complex type, we're prefixing it. Oh, that's not what I meant to do. Prefixing it with the property name that was part of. How many folks have missed this feature from EF Core so far, right? Yep. Now let's dig into, you could do that in EF6. It's not super amazing. So let's go a little bit further. Let's say physical address. We actually want it split out into a separate table. So let's do two table on this. And let's call the table just physical address. Let's drop and recreate. Come back over to Visual Studio and refresh. Not Visual Studio, SQL Management Studio. So if we look at the data here, work address is still inlined in customers. And the physical address is split out into a separate table with just the data for physical address. We introduced a primary key that's also a foreign key back to ensure that there is one record per customer. OK, let's keep going. Let's go a little bit further. Let's introduce a new class called location. Let's pull some of this data down into location. And let's just create a property. So we're kind of doing nested complex types now. So we're going to come back up here and say, in addition to mapping to the table physical address, the address entity in this case also owns one location, like so. And then I'm going to copy that down because that's also true for the work address. Now you may notice I'm being a little bit repetitive here, and that is something that we're still thinking about, whether we want to have APIs that allow me to just globally configure whenever an address is used, it also has a location. Or perhaps we'll just work out if you do this once, then it probably just applies to all usages of the complex type. That's something we're still thinking about at the moment. Let's run. Swap back to Management Studio and refresh again. And we'll see that data now inlined here. And then, of course, also inlined. You'll notice here that we're fairly smart. We know that this is a table dedicated to physical addresses, so there's no need to prefix line 1 and line 2. But location is nested, so we do prefix that by default. Let's keep going. So country. Country might be something that I want to use elsewhere in my application as well. So maybe I don't just want to inline it here. Maybe I want to be able to assign it to orders and stores and things like that. So in that case, country would be a full-on entity. And let's give it a name as well. And then instead of going to country name, let's go to a country, and then maybe we want a foreign key in our type as well. Like so. All right, let's run. OK, so here's country. It gets a full-on table with an ID and everything. And then in my customers table, the country is a foreign key. And same thing again in my physical address. So this is something that you couldn't do with EF6. In EF6, complex types had to just contain value fields. So now we've enabled supporting navigation properties and foreign keys within complex types as well. OK, now we're really going into future territory. What I'm going to show you now is not checked into our working code base. This is effectively a prototype that we have. So this is definitely not committed for 2.0, OK? So just to be very clear, I'm not promising that this next feature is going to be in the 2.0 release. But this will give you a look at what we're thinking of for seed data in Entity Framework Core. That's been one of the really common requests we've heard from people as we talk about the features that are missing from EF Core. So let's load up our last one in this solution. Okay, so I have a very simple blog and post model, except this time I've also introduced tags and users. Fairly straightforward, right? And the other interesting thing is that I'm using migrations for this. How many folks in the room are familiar with migrations and how they work? About half the room, so let me give you a very quick rundown. With migrations, it's used when I'm using EF to create the database schema. So EF you can use to map to an existing schema or create one from your model. So migrations are used when your model is a source of truth. EF has APIs to create the database for you, which is great for prototyping, but you have no way to migrate that schema as you make changes to the model. Obviously not great for production. So that's where migrations come in. I use migrations to work out what's changed between the current state of the model and the last time a migration was created. It scaffolds some code that says these are the changes to be applied to the database. So what I end up with is a well-ordered set of steps that say, do this, then do this, then do this, then do this to bring the schema up to the current model. Each instance of the database records which steps have been applied so that I can point migrations at any database and it will run it through the same set of steps to bring it up to the current schema. In this application, so far I have one migration. And if I open it, that migration just has a whole bunch of create table statements in it to say, go ahead and create all of the initial schema for this model in the database. I don't have any seed data in my database at the moment. So seed data would be stuff that I always want to be there. So model builder, we're going to pull up the configuration for tag and say that tags have seed data because I'm writing a blogging platform that is for technical blogs. And so I want to make sure there's some bootstrap tags in there to help you get started with tagging so that you don't have to watch me type a whole bunch of stuff. Here's some I prepared earlier. So we're putting in this bunch of tags. Now, what's interesting about tags, they're pretty easy because tag ID is a string that I'm providing. All right, it's like a natural key. But that's not always the case. So let's also do some seed data for user. Oh, actually, my snippet has that in. You don't have to watch me type that, except you just did. All right, so we also have some seed data. Now, seed data has a database-generated key. It's an identity set up in SQL Server. But with seed data, quite often I want to actually explicitly say this user should have ID 1 and this one should have ID 2 because they're well-known keys in the database. So that's what I've done here. I've said guest is 1 and administrator is 2, and that will always be the case. Let's come down to Package Manager Console. This is where we use migrations from. I'm going to say add migrations. Let's just call this some data. The name's not important. I can call it whatever I want. Had the wrong project selected here. Let's try that again. Okay, so in addition to diffing the changes in the model, migrations has now also been updated to diff for changes in the expected seed data. Now, I didn't have any seed data before, so it's worked out that there's a whole bunch of new data to be put in the database. So I'm going to insert a whole bunch of rows into tags, and then I'm going to insert a couple of rows into user as well. Now, migrations is nice because it supports up and down methods, so I can roll this migration back as well and just pull out all of that data from the database. Let's go ahead and apply this to the database. So migrations is going to work out that it's already applied the initial create migration to my database. So there's one pending migration, which is my data one, and it's going to go ahead and apply that to the database. I say that. I'm actually not sure that I created the database, so let's... Did I mention this is an early prototype? Initial creation of the database always fails at the moment. So. Okay, so we applied both migrations. So let me backtrack a little bit. I didn't have any migrations applied, so what migrations did is it created the database and then applied all of the steps in order to create it. And I can prove that if I come back over to SQL Management Studio and refresh. Seed data database, users table, select the rows, and there we have guest and administrator. Okay, just hide that guy. What if I want to change data? So maybe I realized that it actually doesn't make any sense to have a guest user in my database because the absence of login information just means they're a guest by default. So let's take that out. And what if I don't like lowercase? What if I want an uppercase on administrator? Because I'm picky like that. So let's go add a migration. We'll call this one fixed data. Again, it's looking for changes. In this case, it's going to detect some changes in the seed data, except it didn't like something here. Why is my build failing? Oh, I probably still have the last one. No, that's not it. All right, give me 1 second. I'm just going to try and work this out. We're not going to pause here for a long time, so if it doesn't work, let's just close Visual Studio and reopen it. Getting that error usually means that I've left the console window open. Let's just try one more time. All right, build succeeded. So now we should be good. So we're still on C data, add migration, fixed data. So it's going to diff the C data in the model, work out that there's 2 changes to be applied. It needs to go and delete the user with ID 1, and it needs to go and update the user with ID 2 to set the username to administrator. Let's just prove that that worked. So we'll apply it, go back to Management Studio, and there we have just that data in the database. One thing, I've never worked out how to increase the font size of that particular window. It's super annoying. Like everything else, font size 16, but I cannot work out what that setting is. Okay, so seed data, obviously a very different approach to what we've taken in the past. And the reason for that is we used to have APIs that would try and, you would tell us the data and we would try and kind of do a diff between the database and the data set you gave us to work out whether things should be inserted, updated, and we didn't really support delete. Because obviously we didn't want to go and wipe out all the data that you didn't tell us about. So the idea of baking it into migrations is that it benefits from all the things that your schema changes make. So there are cases where EF might get it wrong. Maybe you change the ID of the guest, and we're going to translate that as go and delete ID 1, and maybe you made it 999, and so we're going to insert a new row with 999. What you actually want is an update. And so now, because it's scaffolded code that we don't just run under the covers, you're free to edit it, to fix it up, to tell us how we should migrate the data. So some of you in the room might know, I've been a PM on the EF team for quite a while now. A while back, I actually moved to work on some other stuff in .NET. So I was already signed up for this conference, which is why I got to come and talk about EF. But I didn't really work on the stuff that I demoed today. So these are the folks that built all of the stuff that I demoed. So can we get a huge round of applause for the EF team? I kind of got the easy job where I get to come and show everyone all the cool stuff, but I didn't have to do any of the hard work. So these are the guys to thank. All right, a few things that I wanted to point you guys towards. This one isn't specifically tied to EF, but I think it is important for those of us that are trying to build applications in the real world. So we have a new architecture hub, .net/architecture. It's a good place to go. We're going to keep it updated as we come out with new guidance. There's ebooks, sample applications. It's kind of a go-to place to head you off in the right direction for a whole bunch of different architecture stuff. These are some places you can go to next. So if you want to learn more about using EF, either EF6 or EF Core, then docs.efproject.net is the place to go. If you want to get a little bit lower down and help out with EF, whether that's filing issues, improving documentation, or perhaps even fixing some bugs, then we're on GitHub at ASP.NET WAC-EF. And then if you want the source code from today's demos, you want to go to my GitHub repo, which is Rowan Miller WAC Demo EF Core. And actually, I didn't put this one on the slide, but if you want the Unicorn Launcher stuff, that's Rowan Miller WAC Unicorn Launcher. Original, I know. Before you all run out of the room, I know that presenters put this slide up or skip over it because it's super boring. Session evals actually do matter. You might feel like you type some evals into your phone, maybe write some comments, and then it disappears off and nothing happens. But we as speakers actually really do look at the comments that you give us. They've shaped the way that I present a lot. The reason I do very few slides and more demos is because people filled out evals and told me that they really liked just technical demos. So for this session and for the other ones you attend, please take the time to fill out, tell us what you liked, tell us what we could do better, and we really do pay attention. With that, I'm going to stick around up the front and take questions. If the line's too long here, I'm also going to be at the EF booth in the hub probably in about an hour's time. So thank you very much. Enjoy Build.